Okay, so for the next topic here, we will look at the next chapter, which is chapter 4, which is a vector function. Okay, or we can call it as vector calculus. Alright, so basically, what do we know about vector, and what do we know about calculus? So vector and calculus. Okay, so calculus normally we deal with differentiation, integration, alright. And then how about vector? We know that we have a tangent, we have the direction of the vector, and so on. Okay, so we will combine these two, vector calculus, in this chapter. Alright, basically it's not related to the first chapter, second chapter, and third chapter before, but basically we will use the same idea. Alright, the same idea and the same concept that we have learned before. Okay, to describe this vector function. Alright, okay. So basically we have some application in this vector calculus, okay, where we can calculate the velocity, the momentum, the force, okay, and the rest lah, okay, in military usage, okay, projectile, in gaming, and so on. Okay, so these are the related topic that we will learn in this chapter. Alright, vector function and space curve, differentiation and integration in the of the vector, unit tangent, unit normal, arc length. Okay, so that one, motion in space, arc length and curvature tu akan curvature. Okay, akan not included. Alright, scalar and vector field, curl and divergence, and also directional derivative. Okay, so some review. Okay, so basically you already know because you already look at in the engineering maths 1, right? Engineering maths 1, you have look at the vector topic. Alright, you can go through what is scalar, you can recall back what is scalar, right? What is vector, okay, and then the notation, the I, the K, and the J that you have learned before. Okay, and then we have the vector, the position vector, and also displacement vector. Okay, so if you can still recall back, for example, the OA, alright, meaning that if you have from coordinate here A, okay, coordinate A, which is 1, 2, 3, for example. Okay, so if you want to define a vector, so it is, okay, OA, so meaning that A minus O, so 1 tolak kosong, 2 tolak kosong, 3 tolak kosong. So we will have a 1, 2, 3 as the position vector from the origin there. Okay, so displacement vector, if we have another vector B, okay, so we want to get the vector for this tangent and the direction. Okay, so we can have that. Alright, so you can recall back. Okay, so yeah, okay, so component from the vector, we have the either in V1, V2, or V1, V2, V3. V1, V2 is in 2D, and V1, V2, V3 is in 3D. Okay. Alright, so vector form of the line. Okay, so basically if you can recall back, okay, if you want to get the vector form of the line, okay, so let's say we have a line that passing through point P, which is x naught, y naught, z naught. Okay, and then we have a parallel vector, okay, that parallel to the line. Okay, so which is V1, V2, V3. Okay, then we can have the equation of the line. Okay, because the minimum requirement to get the vector, to get the equation in the form vector is 1 point on the line and 1 vector that parallel to the line. Okay, so we can write it as this one lah, in vector form. Okay, so for example R, okay, T equal to R naught plus TV. Okay, so basically the T is normally refer to the time. Okay, and then R naught is the position of the vector. Okay, and then the V here is the vector that parallel to the line. Okay, so for example, for this case, R0 is, for example, let's say P here is anything lah, 1 point on the line. Okay, so for example, 1 point on the line, 1, 2, 3. Okay, therefore we need to find the position vector for that. Okay, therefore it will be vector 1, 2, 3. Okay, so we need to find the OP lah. Okay, OP. Okay, so which is we get that. Okay, plus T, V is the vector that parallel to the line. Okay, so for example, the vector that parallel to the line here is 4, 5, 6, for example. Alright, so we have 4, 5, 6 here. Okay, therefore we can write it as in 1 plus T, 4T. Okay, 4T. Okay, 2 plus 5T and then 3 plus 6T. Okay, so this is the vector form lah, vector equation for the line equation here. Okay, so this is for the line L. Okay, so we can write also in the form of parametric equation. Alright, okay, so it will be in a parametric equation. This vector equation become x equal to 1 plus 4T, y equal to 2 plus 5T, z equal to 3 plus 6T. Okay, alright. So this one in the we have look at the vector form of a line assignment. Okay, so we can rewrite just now what I said. Okay, so vector algebra. Okay, so these are the what we call the rules, okay, or the characteristic. Okay, so if you want to do the addition here, so a plus b plus c can be a plus b first and then plus c, or this one a plus b basically is same as b plus a. Okay, multiplication by scalar. Okay, so if we have k multiplied with b plus c, so it basically is same as k multiplied with b plus k multiplied with c. Okay, alright, so this one is the unit vector, if you still can remember. Okay, so this is the notation for unit vector. Sorry, let's say here u, right? So we have unit vector for u is called it as u hat. Okay, so we have a we need to calculate. Okay, so this one is the vector u over the vector, sorry, vector v, yeah. Okay, so this one here, v hat over v. Okay, alright, so but the notation here is equal to v hat, yeah. Okay, vector v over the magnitude v. Okay, here v lah. Okay, alright. Okay, so the scalar product here we have a dot b. Okay, so you need to know lah, you need to remember. Okay, so a dot b, b dot a, and so on. Okay, so these are the properties for the scalar product. And for the vector product, okay, so we have this one, a cross b. Okay, magnitude a, magnitude b, sine theta. Alright. Okay, and also we have this a cross b basically is equal to minus b cross a, but it's not equal to b cross a. Okay, so this is how we do the cross product. Okay, and this one cross and dot product. Alright.